Made like another one.
Sometimes I do for review guides. I haven't been doing that so far. We don't need to because it's going to be on there. I guess I could do it for all the questions, but nah, sorry. You guys don't deserve that. No one watches it anyway. All right, so I think I did it once, and we had nobody watch. So here it is. Quiz number 3. We've only had 3 quizzes, which is crazy, right? And this is our 3rd one, so really we've only had 2. 1 test. Let's start from the back. So if you open up your hymnals to the last page. Number 11. Again, she's thick, right? But she doesn't have a lot of problems. That's what we like. Only 11. All right, so this should all look very familiar. If you haven't picked up on how things are done, I take all the homework, I mash it all together, change the numbers, slap it together, create a review guide for the quiz. Then I take all the review guides for the quiz, right? And I slap them together and make the review guide for the test. Then I take all the review guides for the test, slap them together and make the final, right? Final review guide, I should say. So you've seen this stuff before, at least twice now. It's going to be on there. So it says given A, B, and C are collinear and D, B, and F are collinear. So we're going to write that down. Given, okay, A, B, C collinear.
Didn't we do this yesterday?
We did. And D, B, F collinear. Now some of the numbers in the letters are changed. Remember yesterday, E for idiot. All right, so those are collinear. That's what we're given. Now, what do we want to prove? We want to prove angle 1 and angle 2 are supplementary. That's something we want to prove. So I'm going to highlight that in red. That's going to get a swag box. 2 and 4 supplementary. That's what we want to prove. Swag box. We also want to prove that 1 and 4 are congruent and 2 and 3 are congruent. Now, we need to assign some colors to this. It's going to help us out. I would encourage you guys, again, to invest in a set of G2 Pilot pens. G2 Pilot, beautiful pens. The 07s are the thicker ones, right? And the 05s feel like writing with a knife. I grade your papers with the knife ones because they're cheaper, and I like to grade your papers with a knife. If you'll notice, the 07s write like this. It glides.
Like what?
Like this. Okay? And then this one is like a knife, right? You see the difference? She thick, she not so thick. All right, so here we are.
Get a red knife. It's like writing.
Edgy. All right, moving on. So what angle, angle 1, what color are we going to do?
Blue.
Blue. Now we have choices, light blue or dark blue.
Dark blue.
It's almost always light blue. They like the light blue. So angle 1 is light blue.
See, dark blue.
Angle 2, what color do you want?
Purple.
Purps. All right, so purple is angle 2. So wherever I see angle 2, I'm going to write a little purple underline, right? What about angle 3?
Brown.
Brown it is. Number 3 is brown. What about 4?
Pink.
Pink it is.
Yeah.
All right.
Green first.
Pink. Pink for angle 4. All right, so we want to prove angle 1 and 2 are supplementary, which means what?
They're 80.
Add up to 180, right? Okay, so that's what we need. This is the same thing we did yesterday, except I put it in a different order because we're going to get 1 and 2 are supplementary a lot faster than we're going to get that 1 and 4 are congruent. Okay, so how do we prove 1 and 2 supplementary? We know that A, B, and C and D, B, F are collinear. What can we grab out of that? If those points are collinear, then they must form what? They form a line, right? So let's write that. So starting out, A, B, C and D, E, F or D, B, F are lines. Now I could write are lines next to that, but notice when I put the symbol above them, that implies that they're lines. So I'm not going to do that. I just know that by definition, because if the points are collinear, then those guys must form lines, right?
How do you know, like, when you write it out that they're collinear? Like, what tells you in the written form that they're
A, B, C are collinear, D, B, F are collinear. It's given to
Yeah,
us.
I know that, but when you wrote A, B, C, and D, B, F, what says that they're, you know what I mean?
That they're on a line?
Yeah.
Okay, so if I have 3 points that are collinear, it means they're on a line, right?
Yeah.
So if the 3 points are on a line, then the line that's named ABC
alright.
must be a line. No, it's a good question because it's so simple, and we haven't really defined how to define a line, right? It's just one of those things where I know it when I see it, right? Those guys are collinear, which means they form a line. Those guys are collinear, which means they form a line. Cool? That's all. So, great question. From there, we know those are lines. What do we know about angle 1 and angle 2? How are we going to get them in the same equation?
angle 1 plus angle 2 equals 180.
They equal 180. Now, we can't just write that. How do we know they're 180? Because they're a linear pair, right? And linear pair says 2 angles on a line, right? Pair meaning 2, linear meaning line. So look, they're on a line, and we have 2 angles. So I know, because those are lines, that angle 1 and angle 2 are a linear pair. And I know that they're a linear pair by definition, right? Linear pair says two angles on a line. Do I have that? Yes, I do. There's the line, ABC, and there are your angles, right? Cool.
Now you can put it in.
So now that they're a linear pair, what thing tells us that they're supplementary? What theorem?
The
Addition postulate.
We're not adding them up.
It's angle or did.
Nope.
No.
That says the two angles add up to the big angle. That's something like that, but we don't know the big angle is 180. We could do that, right? You could say 1 and 2 add up to the big angle, and the big angle is angle ABC. And ABC by definition is a straight angle, and straight angles are 180.
LP.
Do some substitution, right? You could do that. I'm going to use linear pair theorem. Basically, what you were describing is how we prove linear pair, right? You would say the whole thing's a straight angle, therefore it's 180, therefore those add up to 180 by angle addition postulate, do some substitutions, yada, 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 therefore they're supplementary, right? I'm going to say by linear pair theorem, angle 1 and angle 2 are supplementary. That's what linear pair theorem says. It says if you have a linear pair, which we do, then they must be supplementary.
So if we explain it like that tomorrow without like just saying LBT is still right.
You need to include this.
Alright.
That's the whole explanation right there. Okay? So 1 and 2 are supplementary by linear pair theorem.
Will we take it points? Like, would it be minus half or something?
I'm not sure. I'm not sure if I'm going to make this worth more than this part. I think I will, but I got to think about it. It won't be all your points, but it will be most of them.
Most, yeah.
Or at least half, I should say. At least half. So 1 and 2 are supplementary. We know that because linear pair theorem says they are. If you have a linear pair, then they're supplementary. Now, what does it mean to be supplementary? Oh, pause. Actually, guys, we just won. 1 and 2 are supplementary, right?
Oh.
So we're done. Boom.
Bye-bye.
I'm going to box it like this, and that's going to be my swag box.
Can you at least put a little box in the corner?
Sure. Okay. We also wanted to prove that 2 and 4 are supplementary, right? Wouldn't it be the same dumb crap?
Yes.
Check it out. We said 1 and 2 are a linear pair by definition. Therefore, they're supplementary. Therefore, they... Right, that's it. That's it. Couldn't we do the same thing with 2 and 4? 2 and 4 are a linear pair. Therefore, they're supplementary by linear pair theorem. Done, right? So I'm going to save some time and just say, from here, angle 2 and angle 4...
Whoa, that's a weird one.
Angle 4 we did in Pank are supplementary by the same dumb logic, right? So by similar logic,
Did I not get this packet?
I don't know, it's back there.
It's number 11.
Yeah, I had like
Maybe you missed the back page.
no, I don't have it at all. Like I had number 5 or something. Oh, back here. Okay.
Her rockers.
So that was our other thing we needed to prove, right? So there's our other little swag box. Beautiful. Okay, now let's go further. We want to get 1 and 4 in the same equation, right? In the same room. Well, we have something with 1 and 2 and 2 and 4, right? So let's make those equations and try to, get them together. So if I know 1 and 2 are supplementary, what does that mean? Yep, the measure of angle 1 plus the measure of angle 2 equals 180.
And the same thing for 2.
And that is by definition, right?
Yes.
And then the same thing for 2 and 4, as Rosie said. We had a chance in 4th hour. I was asking him what supplementary meant, and he didn't get it at first, but got it with a hint. And he was so excited that he got it, he said, "Hell yeah!" And I was like, that's amazing. We should do that every time we get a right answer.
You said that?
Chance, yeah. Shout out to Chance.
Yeah.
Hell yeah! He was so happy.
He was in my geography.
That's our football.
He's dope. He's dope. All right, so now we're here. You might notice they have 2 in common, which is great. You could rearrange it and do 2 equals 180 minus angle 1, and then take that and plug it in, right? And it would work out, right? Because 1 and 4 in the same equation is if they're actually equal, then all the math should work out where it shows they are, right? But there's an easier way. These guys equal 180, and these guys equal 180. Therefore, they equal each other. You smell what I'm stepping in?
Yep.
All right, so let's write that. Measure of angle 1 plus measure of angle 2 is going to equal measure of angle 2 plus measure of angle 4.
Then you want to get rid of
Yeah, get rid of the 2, right? And we did that by subs. S-U-B-S, substitution. Don't forget the S tomorrow. I swear to God, I'll mark it wrong if you write S-U-B. Okay? That could be subtraction. It could be substitution.
Because you like subs, huh?
You what?
You like subs, don't you?
That was dumb, shut up.
Yep.
Yeah, I did.
I'm sorry I asked what. You could have got away with it. My bad, bud. All right, so what we're going to do next is subtract angle 2. Now, again, we're not subtracting it from both. I mean, we are subtracting it from both sides, but it's not just like, oh, they're the same, they go away. Like, that doesn't always happen. But, like, when you subtract angle 2, it becomes negative, right? And so we have a positive version and a negative version. They do go away, right? Just because there's, like, similar things on both sides doesn't mean you can just be like, oh, cancel everywhere, right? The reason it cancels is because when we subtract it, it does actually go away. It becomes 0, right? We're subtracting it from itself. Okay, I probably shouldn't have even mentioned I'm confusing you guys, right? We're going to subtract them, they're going to go away.
Wait, so, there could be a circumstance where,
Imagine that we have multiplication, like you have like x times y on one side, and then you have 1 plus x on the other, right? When you get rid of that x, you're not going to get rid of it on both sides because one's a plus x and one's a times x, right? Okay, you divide everything by
is
x.
that gonna happen?
It's the subtraction, it's going to make them go away. All right, so when we subtract angle 2 from both sides, because it's already there, it goes away. Right, like, Rosie, here's another example. See how there's an angle 1 and an angle 2 and a 180 here? Okay, if I subtract angle 2, right, does that mean angle 2 goes away? No, it just moves over. Now, the reason this goes away is because there's one here and one there, and one's positive, one's negative. Okay, cool. So we know this, and we got there by subtraction, right? That's subtraction property of equality. SUBT. Not quite, because they want to show that it's congruent, and right now we have equal. So we know that if the angle measures are equal, then the angles themselves must be congruent, right? So our last step, which we get for free, so we put a little therefore symbol. I put therefore all the time, even if it's not for free, but do it especially if it's free. I mean, you don't get to use therefore that often.
We love free stuff.
Yeah, we do. So therefore this, and we win, right? Ta-da, swag box. Okay. Now by the same dumb logic, we're going to prove that angle 2 and angle 3 are the same.
So you can put by the.
You're right. Haley, good job. We forgot our tilde.
Oh,
Anya,
I
right?
did that.
Como te llamas?
What does that mean?
I believe it is. How are your llamas? Actually, be como tu.
Yes.
So we're here. 1 and 4 are the same. Cool. Notice up here, here's what we did to prove that 1 and 4 are the same. Here's 1 and 4. We said 1 and 2 are a linear pair, therefore they equal 180. We said 2 and 4 are a linear pair, therefore they equal 180. Therefore, 1 and 2 equals 2 and 4. We got out the middleman, right? And then 1 and 4 equals each other. That's what we did. Same dumb crap with 2 and 3. So notice 2 and 1 are a linear pair, so they equal 180. 3 and 1 are a linear pair, so they equal 180. Cut out the middleman. 2 and 3 must be equal. So it's the same thing we just did, just with different angled numbers, right? We're talking about 2, 3, and 1 instead of 1, 2, and 4. So I'm going to write same dumb crap. Same dumb crap.
You really want to
Can we do this?
Yeah, you can write that. Angle 2 is congruent to angle 3. And angle 3 we did in brown.
I can't even tell what's brown.
Swag.
I'm just gonna box.
Swag cube.
So we can just box it.
It needs to be swag though.
It needs to be swag. Minus 1,000,000 points if you don't have swag.
Fine.
Dang it. It should be extra credit if we have an hour.
Extra credit? Yeah, extra. You think I did extra? What an idiot. All right. No, are you kidding me? No, extra credit's ridiculous. You know what the typical extra credit is? You bring in Kleenex boxes and literally the rich kid buys himself a good grade, right? Like, why not just like cut it out and like give no grades and just like give you a grade based on your parental income at that point, right? It would save everybody time and it would be just as valid. So if we're gonna do that, let's just do that, right?
Well,
My dad's
Right?
a teacher.
Your dad's a teacher?
Yeah.
Oh, no way. What does he teach?
Trig and welding.
Trig and welding. That's nice. Where does he teach?
He works at the training center in Rock Island.
Rock on. Rock on. I didn't mean to do that. Number 10. Let's take a look at that. How do we feel about 11?
Horrible.
For real?
Hold on, wait, yeah.
Not
All right.
much count.
Let's walk it through. I'm going to bring you through the logic real quick. Okay, so here we go. We're given that they're collinear, therefore they're lines.
Yeah.
If okay, so we're given that they're collinear, therefore they're lines, right? And if they're lines, then ABC is a line. That means those angles are sitting on a line, right?
Yeah.
So I can call them a linear pair. Two angles on a line, linear pair.
Yeah.
And if they're linear pair theory says they're supplementary.
Yeah.
So we win. Same logic, 2 and 4 are going to be supplementary as well. See how they sit on their own line too?
Yeah.
Okay, cool. If they're supplementary, you know that means they add up to 180. Hell yeah, right? By definition, same thing here.
Alright.
If they both equal 180, then they equal each other.
Alright.
And we can see that angle 2 and angle 2, when we subtract them, go away,
Alright.
which means they're congruent.
Alright.
Okay? Don't try to memorize this. The numbers and everything will be different tomorrow. But understand the flow, right? They're lines, linear pair. Supplementary, right? Because they're on a line. They got to add up to 180. Supplementary means this. They're the same thing. Things go away.
Bless you.
Okay? Enough! Jenna was absent today. She's been absent the last couple of days, and my class has been so germ-free. All right. Thank God for her staying home. Get better, Jenna.
She was literally here yesterday.
Nope.
She wasn't. Definitely not.
Definitely not. Oh, yeah. Angle 1 and angle 2 are supplementary for number 10. 3 and 4 are supplementary. 2 is congruent to 3. Prove that 1 is congruent to 4. What color do you want for angle 1?
Purple.
Aww, twinsies. All right. Angle 1. Angle 2.
Homecoming Court 29.
Blue. All right. Number 2 is blue.
Orange.
All right. Didn't they tell us that 2 and 3 are the same? So let's keep them the same color. How about that?
And then 1 and 4.
How about that? Oh yeah, one more. Yep.
Well, then,
This guy. Let's make 4 pink.
Tank.
Pink. So we're gonna try and prove that 1 and 4 are the same. That pink is the same thing as purple. So here we go. Write down what you got. Well, we're given that angle 1 and angle 2 are supplementary. We cannot write they equal 180 yet. That was not given to us. We know that because we're smart. Okay. So 1 and 2. I know. I lied. Angle 2 are supplementary. You're all dinguses, but you're my dinguses. We also know 3 and 4 are supplementary. Dingai. Bunch of dingai. Eh? Frickin' dingus. All right. 1 and 4 are supplementary. And we're also given that 2 and 3 are congruent. Yay, colors.
Is it ever gonna annoy you to keep switching pens?
Nope. So, been doing this for years, baby. All right, so notice, we need to get purple and pink together. That's what this says, right? Well, we have a purple, we have a pink, but they're not together yet. But notice the connection, right? We got some blue here. So that's the bridge. That's the bridge. 2 and 3 are the same, right? Okay, so let's start with one of these, and then we'll move our way out to the other. We know what we know what supplementary means, right?
Yep.
Okay, so by definition, what does that mean?
Equals 180.
Measure of angle 1 plus the measure of angle 2 is going to equal 180.
It's always 3.
And we know that measure of angle 3 and measure of angle 4 by the same logic is going to be 180, right, by definition. So we got some blue there and some pink over here. Again, I would encourage you to get these pens. 17 bucks. Sponsor me, Pilot. Or get other pens, you know. I don't care. I just think these are really nice. And they'll last you the whole year. They won't last me the whole year. I got to buy new ones every 3 weeks. Sponsor me, Pilot. All right, so here we are. By definition, that's true. Cool. So what do you notice? They share this, right? But that's not perfectly the same. We need to switch that out for a 2 and then rearrange stuff and then plug it in, right? But they equal each other because they equal 180, right? So let's go with the easy one. Measure of angle 1 plus measure of angle 2 is going to equal measure of angle 3 plus measure of angle 4 by substitution, right? Because we're switching out 180 for 3 and 4. Again, what used to be 180 on this side, we're now switching that out for this because it is 180, right? It's the same dumb crap, just different way of writing it. Potato, potato.
So aren't you basically just combining the two, right?
Yeah, right, and we can do that because look, this one says equals 180, right? Well, we know that another name for 180 is angle 3 plus angle 4. right? It's the same way. It's just a different way of saying it, right? But now that we see this, look, that's going to go away and we get what we want, right?
Yeah.
It's just 180 by a different name. That's it. It's the same dumb crap. Same dumb crap. Right, I call you Kayla, call you Carpenter. It's all good, right? Same thing. We can call her Kayla or Carpenter.
Same dumb crap.
Same dumb crap. You piece of human garbage. All right, so now we're here. We could subtract these two and they go away because we know they're congruent, but we haven't stated that, right? It's just because it's in color that we know it to be true, right? So what we need to do is switch out the 2 for the 3 or a 3 for a 2. Which one do you want to switch, the 2 or the 3? 2. Let's switch the 2. So I'm going to write the same dumb crap, except instead of calling it 2, I'm going to call it 3 because, again, just the same name, just a different way of calling it. So the 4 and the 1 stay. And I'm switching out the 2 for a 3, you said, right? So that stays a 3, and that changes to a 3. When I switch stuff out, we call that what? Substitution. S-U-B-S. I forgot my S last time. -1, Mr. Mac. By subs. And now you see the magic, right? We're going to subtract angle 3 from both sides, and it's going to go away. Kozovic, you with me? Sí. Muy bien. So how do we get there? Well, we subtracted angle 3 from both sides, so that's by subtraction, S-U-B-T. Don't forget the T. And we're almost done, right? They wanted to show that it's congruent, so let's write it as that. Little enya over the equal sign. And swag box! Yeah, there it is. Triple swag, quadruple swag, so many swags, all the swag. I got bored. I'm sorry.
Yes,
it
It's
is.
just slop.
Shut up. That was obnoxious.
I like the 2 swag boxes better.
I'm going to make you moderator.
Extra swanky.
Ban him. All right. Questions on that?
Get it. I'm a whole-
Are we starting to get the idea of it's supplementary, they equal each other, right? For up here, it's the same thing, but they're complementary, right? So what it's going to be is that 1 and 2 are complementary. What does it mean to be complementary?
90.
That's right, so they equal 90. So 1 and 2 equal 90. Thomas, if 2 and 3 are complementary, what do they equal? 90. So 1 and 2 are 90. 2 and 3 are 90. So they must equal each other. So 1 and 2 equals 2 and 3. What do they have in common? The 2, right? Subtract the middle guy, we get 1 equals 3. There it is.
Why do I understand?
Hi, you're just tuning in, aren't you?
No.
Okay.
Maybe.
Okay, you were writing stuff down, so let me run through it again. Okay, because I'm not going to do it. We've already done it in the homework, and this is the same dumb crap as the last one, just fewer angles, okay? So 1 and 2 are complementary, that's what it says, right? So 1 and 2 equals 90.
Yes.
Now it says 2 and 3 are complementary, so 2 and 3 also equal 90. So 1 and 2 equals 2 and 3. Cut out the middle guy, therefore 1 equals 3.
Do you understand that here?
That's the gist. So again, it's the same thing as down here, except it's going to equal 90, right? That 3 is just going to be a 2, and that 4 is going to be a 3. The 2's are already the same. We subtract them after putting them equal, right? We set them equal to each other. We subtract them, and they're gone. It's the same dumb crap. It's just you don't have to switch out the 2 for a 3. It's already going to be the right thing. Yes, sir.
For that one on number 9,
Yeah.
can you classify angle 1 and angle 3 as vertical angles or not?
No, they're not vertical because they're not opposite angles. So if I were to extend this line out to here and there, those would be vertical, right? Because there's the scissors, right? Those two are not a pair of scissors, right? You tell me how to get a pair of scissors to open up like that and to the side like that. That's not going to happen, right? But here we have scissors. Okay? Good question, good question, good question, good question. 7 or 8?
7. No, 8.
7 or 8?
8.
Everyone fears 8.
Or which one's worse, 7 or 8?
I actually think 7 is, but I'll show you 8 real quick, and I'll show you why it's not so bad, okay? We did it one way because that's the way everybody saw it, and I went with your way of seeing it. I'm going to show you my way of doing it, okay? So check it out. X, Y, and Y, Z, they're the same thing, so I'm going to make them the same color. X, Y is pink, and Y, Z is pink because they are congruent. I'm going to use light blue. X, V, and VU are the same because it says so, so I'm going to make them both blue, and they're congruent. Now, if you're doing this at home without color, you'd have to use double tick marks for this because we don't know that these guys are congruent to the pink guys, right? We don't know that, okay? However, you'll notice in a second, XY, what color is XY? Pink. So we have a pink, and then what's VU? Blue. So we have a pink equaling a blue. That's going to be the bridge. So that's the thing that connects them, right? And so now we need YZ, which is pink, congruent to XV, which is blue. So again, here's the given. Here's what we want. So notice, we already have a pink and a blue, don't we? That's good. They're just the wrong letters. So if only we had a way to switch out XY for YZ.
Substitute.
Yeah, right, there it is. If only we had a way to switch out VU for XV. And we're done. That's it. Okay, so last time we started with like this guy and worked our way towards that, right? We had very little in common. That's fine, you can do it, right? It's gonna work. Let's start out with the most in common and then just switch the letters. So given all this stuff, let's write that out. I know it's gonna be a pain to write it since you now know the solution. But given that XY is congruent to YZ, and given that XV is congruent to VU, I tried to be efficient here and I screwed it up. And we have that. That's all that we were given. So notice I'm going to start with this one because it's already pretty close, right? So I'm going to write XY is congruent to VU. And again, where do we get that from? It was given, right? You need to write the givens tomorrow. It's free points and it'll help you. And it's necessary when you're doing a proof. So we are given that, right? So how do we make XY look like YZ? We switch them out, right? Literally, here it is. XY is YZ. It's the same dumb crap, right? So switch it out. We're going to write YZ in here instead. Technically, we could make this a one-step proof, but I'm going to drag it out just a little bit. By substitution, right? SUBS. I swear to God, don't forget the S. I will mark it wrong. So now we got YZ. How do we get VU to look like XV? Substitution, right? VU is XV. That's what it says, right? So we can switch them out. So next step is the same thing as last time. It's just this time I'm going to switch out the VU. I'm going to write it as XV. And that was by substitution. Now, we're done. Because that's what they wanted.
What's the bottom one by subs?
Yep, both are by subs. Technically, you could combine that into one step and just switch out X, Y, and VU at the same time. Both by subs, right? Yeah, that one's not so bad, huh? If you see it. But seeing it is the hard.
Swag box pretty much shows that like you're done.
Yeah, that's all it is. Yeah. There's two official ways to end your proof. You can write Q.E.D. QED. Okay, QED is basically Latin for the proof's in the pudding, right? The proof's done. Or you can just do a box. I do double box for the swag. No. I just think that's a good way to do it.
As long as you know where your answers are.
Yeah, right. I just need to be able to see your answer or your finished product, right? I just think that's nice looking. So that's the gist, right? Yes, sir.
Can you just give me a quick rundown on what we did again?
Yeah, absolutely. Yeah, I was flying. So we were given all this crap, right?
Yeah.
So I started out with this one, and I chose that because look, it's very similar. We got a pink and a blue, right? Now the only thing that's different are the letters. That's XY, that's YZ, and that's VU, and that's XV, right? So I need to switch them out. Well, luckily I know XY is YZ, right? So that's what I did. I switched them out.
Okay.
And that's what we want, right? Now, same dumb crap for VU. I know VU is XV. So I switched it out. And look, now we have what we want.
Okay, I got you.
Yeah. I'm glad you're asking, right? Not because, oh, it's such a dumb question, it's so simple, right? That's great. That's when you need to ask those questions because something this small is causing you this much of a problem because you'd miss all of that, right? So just ask, and then I can be like, no, it's not that, and we're good, right? If you don't ask that, you're going to be held back by this thing this big, and that's stupid, okay? That's the real stupid thing. Please ask questions. You want to look at number 7?
Yes.
Yeah, why not?
All right, JK is LM. So I'm going to use the same color. Let's use light blue again. JK is LM. We want to prove that JL equals KM. So JL is this dude. Right, that's JL. And KM is this dude. I used red on accident. All right, so that's what we want to prove. That's what we're trying to get to. Now, what do we know about KM and JL?
There's,
They equal each other?
Because right now we've got we've got colors that are completely different, right? Here's what we're given. Here's what we need. There's no connection there. So how can we think of KM or JL in terms of blue?
Linear JK's inside.
JK plus what? KL should equal JL. Smell what I'm stepping in? The two little bits add up to the big bit. What postulate is that? Segment, addition, postulate, right? We're doing segments, we're adding them together. Postulate because it's so obvious, right? Of course the pieces add up to the thing.
Couldn't you just
Oh,
say
that's
that,
sad. I mean, sad.
Can you say JK plus KL equals, or, you know, what I don't know.
JK plus KL equals JL?
Yeah, did you say that?
That's right. That's what we're going to do.
Whoops.
No, it's all good. No, it's cool. Don't be mad. All right, so JK. Okay, JK plus KL. Now, KL we haven't given a color. Let's have that be, I don't know, how about green? KL is this bit.
Yes.
So JK plus KL is going to equal the whole dumb thing. What's the whole dumb thing for that one? JL. JL. All right. Same dumb crap here, except it's going to be LM plus what? KL. Okay, KL. I'm going to keep it KL just to keep it consistent. It's easier to see that those are together, right? Equals KM. And I'm going to write KM because that's how they wrote it instead of MK. Okay. So now we're here. You might notice that these things are almost equal to each other, right? That's what we want to get together, these two, right? Well, we already have the KL lined up. If only these two were the same, they'd be the exact same thing, right? So let's switch out one of them. Which one do you want to switch out, the JK or the LM? Okay, we're going to switch out LM for JK. We can do that because they're the same dumb crap, right?
Yes.
I didn't write my givens, sorry. Here's the givens. You forgive me? Forgive me for my givens. All right, so we're going to rewrite that. The top one, let's rewrite that
Can't we just put same crap?
as LM plus KL equals JL. It's not the same dumb crap. It's different. One ends in JL, one ends in KM. We don't know that those are congruent yet, even though they will be. So notice now, here are the two equations I'm looking at, number 1 and number 2, right? Well, if LM and KL equals KM, and LM and KL equals JL, don't these guys have to equal each other?
Yes.
Right? So by substitution, let's write JL first, because that's what they wanted, right? Equals KM. Now, why is that substitution? Check it out. This is what used to be written there, right? Look at equation 2. It's the same as this. It ends in KM. What used to be there was LM and KL, right? Well, I know that LM and KL is JL by another name, right? It's just a different name of LM and KL. JL. So whenever I see this, and I see it here, I can switch that in. So instead of writing this, I'm going to write JL there. That's what I did. Again, JL is that. So when I see that, I can just write that, erase all that, and say, that's just JL. So I get JL equals KM, which is what we wanted.
So are you saying that the top row right there, JK plus KL equals the LM plus KL equals JL?
So this thing right here
Yeah.
is JL. So whenever I see that, and I see it right here, I can scribble that out and just write JL instead. And look what I get, right? That's what substitution is. It's taking something that's the same thing as something else and switching it out. It's the same thing by another name. Same dumb crap.
Okay, he doesn't teach like trig. He teaches like something
I understand.
in that area.
Yeah, I understand. Turn the page. 5 or 6?
Taught me 5.
5, which is literally the same as the homework. All right, so 5. Given D is in the interior of ABC. So first of all, let's draw angle ABC. I'm feeling a little obtuse, so we're going to make it an obtuse angle. Why? Because I like lots of room to be able to write. Acute angles are small. Oh, look, ABC is obtuse. Yay, wonderful. If it wasn't, it still wouldn't matter. We aren't drawing to scale. All right, so that's ABC, and D is in the interior, right? Well, here's D in the interior. Okay? Now, how do we know this is the interior and not this? I don't know. I think people just like the smaller part being the inside. I don't know. Right? The house is usually smaller on the inside than the outside. Usually. But I thought about that today. I was like, I don't know if that's defined. All right, angle ABC. What color do you want ABC to be? Purple it is. ABC is 165. That's the whole dumb thing, right?
Yes.
And they give us ABD. What color is ABD?
Blue.
Blue. Dark blue it is. I know. ABD, it's this bit, is x over 3 plus 45. CBD, as in the oil. Dicamo, what color?
What color is he at?
Orange it is.
Yeah, I wanted to spice it up, okay?
That's right. We're all about the spice. So that's going to be 3x plus 20. Now, we want to prove that ABD, that's our, what color angle? What color is ABD? Try again. ABD is blue.
Dark blue.
That's right.
Navy.
Yeah, it's dark blue.
This one's navy, which is different from black. I didn't because it's so similar to black.
Wait, so is the purple, is not the purple, the orange, is that from
Oh, yeah. Let me highlight the orange, yeah.
BBC?
CBD. Yep. Yep. Same thing. Okay. So we need an equation because, right, we have ABD equals something with numbers. So right now we don't have any equations. We just have expressions. See no equal signs here? So how do we set those all equal? What do we know?
What do we know? I don't know.
Hold on. DBA plus what? DBC should add up to what? ABC, the whole dumb thing. So we have the pieces adding up to the whole thing. What postulate is that? Not segment.
Angle.
Angle addition postulate. AAP. Says we add up the angles and they equal each other. So what angles are we talking about? We're talking about angle ABD. Make sure you write it the way they do, not DBA. That's the measure. Plus the measure of CBD, right? Again, write it the way they do. Don't do DBC. It's going to confuse you. Equals the big angle, which we're going to call ABC, right? That's how they called it. Now we're here. That's angle addition postulate. The two little guys add up to the big guy, right? Now we're going to substitute the values. So, Rosie, what is the value of ABD that they give us? It's not a number. It's a bunch of stuff. ABD equals what? Thank you, Kozovic.
Yeah.
Rosie, try again. What's CBD?
CBD.
You chill, CBD. 3x plus 20. Thank you very much. Drug reference. All right. And ABC is just 165, right? We did that by substitution. We switched them out, right? SUBS. Don't forget the S. Now we just do algebra from this point forward, right?
Yes.
So let's do that together. 45 and 20 are on the same side, so I don't need to do any special properties here. It's just adding, right? 45 and 20 is going to make 65. They're on the same side. And then 3x and x over 3 are on the same side. How many thirds are in the number 3?
3.
Try again. 9 thirds, right? 9 over 3 is the same thing as 3. So we have 9 thirds plus 1 third. How many thirds is that?
10 thirds.
10 thirds of x. Subtract the 65 by subtraction property, multiply by 3, divide by 10, yada, yada, yada. We get that x is equal to what? 30. Okay, yada, yada, yada. I skipped a bunch because we're running out of time. Are we done? No. Go back, plug it back in, prove ABD is 55. Okay? The front page is very easy. It says they're collinear, so draw a line, put them down, and do your thing. Should feel like the first quiz we did. See you later. If you want to watch other ones, I got through more in my other hours. Check out those videos.
You know the split 25 so did I ever get points?
You get points for that. Yeah, I just haven't gotten through it. I gotta go through and shift through them all, and then I'll post them. It's a lot of work, but I'm gonna try to get it done this weekend, if not next weekend.
This weekend, if not next weekend.
Yep.
We were talking about CBD oil, Parker.
Always.
Really?
Yeah, why is he in here? Who is this dude?
I was showing him around the school.
Okay, new dude? No. New dude. Hey, new dude. I'm Mr. Mack.